This video is about problems and solutions on selected physics topics. A vector has an x component of minus 25 units and a y component of 40 units. Find the magnitude and direction of this vector. Okay, it is oftentimes useful to draw the vector to get a clear picture and clear understanding of the problem. Okay, we place the vector on the xy axis. Xy, the vector has negative 25 units in the x direction, which is the negative x direction. So we draw the component vector 25 units and 40 units in the positive y direction. So from the drawing we know the actual vector is actually this one, and it is located at some theta degrees from the positive x-axis. Okay, from the information we are going to find the magnitude of this vector A, and then we know the components of AX vector, which is equal to minus 25, and the AY component vector is 40. So magnitude of the vector A is equal to the square root so we get 47.2 units. So that is the magnitude of the vector A. Direction of vector A, which is theta, is equal to tangent inverse AY divided by AX. Tangent inverse 40 over minus 25. So theta equal 122 degrees. So the magnitude and direction of this vector A is just 47.2 units, comma 122.0 degrees angle, direction angle. So this is the answer. Okay, next question. Obtain expressions in component form for the position vectors having the polar coordinates A 12.8 meter, 150 degrees, and so on. Okay, let's try the first one, A. So A, position vector having polar coordinates is given as 12.8 meter, 150. Okay, let's express this position vector in terms of component form and in terms of unit vector. Okay, first we draw the position vector on the xy coordinate. So this is the position vector P, and the angle 150 degrees. And we have its component Py, and here is Px. Okay, we can make use of the small angle alpha between P and Px here, where alpha is equal to 180 degrees minus 150, which is equal to 30 degrees. And the component Px is equal to P cosine alpha. So P cos alpha equals 12.8 multiplied by cos 30 degrees. So you will get 11.1 meter. Similarly, for Py is equal to P sine alpha equal 12.8 multiplied by sine 30 degrees, and this equal to 6.4 meter. So okay, before we accept this calculation, we have to check the signs in front of the component value. Okay, for example, like the px should be negative because it is pointed to the left of x-axis. So this one should be negative. Okay. Okay, finally we can now write the finally we can now write the component form of position vector P. Okay, kita boleh tulis P, it is Px, Py. Okay, this one is actually equal, P negative 11.1 meter, and Py is 6.4 meter. Okay, that is the component form of position vector P. Okay, how do you write the position vector in unit vector form? Okay, dalam unit vector, macam mana kita nak tulis vektor kedudukan ni? In unit vector form, P is equal to negative 11.1 I direction, which is in x direction, plus 6.4 j direction. Okay, all in meter. Okay, so you guys can try to answer part B and part C. Okay. Okay, next, this is an interesting problem. This is about path taken by a spelunker. Do you know what is a spelunker? Spelunker is one who makes a hobby of exploring and studying caves. Right, one who explores and study caves. Okay, so how is her movement? She goes 75 meter north, then 25 meter east, 125 meter at an angle 30 degrees north of east, and 150 meter south. Okay, let's draw her path. Okay, we will use a compass marker here to trace her movement. Okay, she starts here, 75 meter north. Okay, 250 meter east. Okay, at an angle 30 degrees northeast, and 150 meters south. 75 north, 250 east, 125 at an angle of 30 degrees. Here, 30 degrees, and 150 meters south. So this is 150 meters south. So okay, we are supposed to find her resultant displacement. So that means this one, this vector from the beginning to the end. Okay, so this is the resultant displacement R. Okay, so figure ni, lukisan ni tak tepat ya. Jangan ingat resultant vector ni horizontal 100%. Okay, tak semestinya. Tapi this is the challenge. We have to determine the actual displacement vector R ni. Okay, kita labelkan displacement vector perjalanan dia dari mula hingga akhir. So D1 is displacement vector number 1, D2 displacement vector number 2, D3, and then finally D4. So the resultant displacement vector would be R is equal to the sum of all displacement vectors. D1 plus D2 plus D3 plus D4. Okay, so we do the vector addition by using component methods. So that means we have to find component for each displacement vectors, and then we add all the like components to get the resultant component vectors. Okay, so like this, macam ni. Komponen bagi X untuk resultant vector Rx adalah jumlah semua komponen vektor dalam Rx setiap D1, D2, D3 dan D4. Begitu juga untuk Ry, D1y tambah D2y, D3y dan D4y. Okay, so apakah X komponen untuk D1? D1x has no component in the D1 has no component in the X direction. So D1x is 0. D1y magnitude dia 75. Untuk D2x 250, tetapi D2y tak ada komponen, 0. Okay, for D3x, D3y, dia ada komponen X dan Y. So this one you have to find it separately first, sebab the vector D3x is at an angle of 30 degrees. Okay, so meanwhile, untuk D4x, 0, and D4y ada komponen vektor, tetapi komponen vektor dia menghala ke bawah, downward. So you have to put minus 150. Okay, so we find the components for D3 specifically. So that is D3x equal D3 cos 30 degrees. That is 108.25. 108.25. D3y is D3 sin 30 degrees. So this one kita dapat 62.5. So jadi we can fill up the D3x component, which is 108.25, and D3y is 62.5. Therefore, Rx is equal to 1 dx 0 plus 250 plus 108.25 plus 0, and Ry is equal to, so the sum of all the x component of these, kita dapat Rx 358.25 meter, and the sum of y components of these, kita dapat Ry, which is, so kita dapat negative 12.5 meter. So component of Rx is to the positive x-axis, and component Ry is to a negative y-axis. And the resultant displacement is located below the x-axis with an angle theta here. Magnitude of R is equal to 358.5, sorry, 0.48, 0.47, 358.47. Angle theta, angle of the resultant displacement theta is equal to 2 degrees below the x-axis. Therefore, her resultant displacement is R with a magnitude of 358.47 meter, and the direction angle is 2 degrees below the x-axis. So that's the answer.